Now you can see. So this is also Arduino layout only, but here somewhat good description is provided here. Here that the pins, which pin can be, because in Arduino this is a microcontroller, only few pins can be communicated with the real world. Only few number of pins are kept for outside real world communication. So here a few digital pins are there, few analog pins are there. See, these analog pins can be used for digital communication purpose also, as well as an analog purpose, as well as some serial communication, as well as this you can see this color. This is AVR. I too don't know what is this AVR is, but you can search it in Google. You can Google it, and here you can see this color represent. This also for AVR means. Uh, as of my knowledge, AVR means a PC not here. For example, in Arduino, you can see three different kinds of ports are there. So here you can see PC means port C. Here PB means port B. PD means port D. So here a few ports are kept outside. Means this is you can see if you work with real-time microcontrollers. In these microcontrollers, few ports are kept outside, and that port pins only you can use for communication. But this Arduino has made something much easier, and these port names are remodified into digital pins and analog pins. Okay, so here for few pins you can give external interrupts. So interrupt pins are also separated. Okay, and here you can see with red color PWM pulse with modulation pins are also provided. This is a schematic layout of Arduino. Now coming to the multifunction shield. This is multifunction shield, which now you are going to use it. In this multifunction shield, where this is a layer on top of the Arduino. So on the top of the pins of the Arduino, you will just fix this multifunction shield. It consists of, you can see, LEDs are there. Here 4 LEDs are there, D1 to D4, and three push button switches are there. With this LEDs, you can make digital operation. With this pushes, you can make digital input to microcontroller. This LEDs can get with the digital output as well as PWM output and log output. So many ways LEDs can be controlled. Digital output means either LED on and off. PWM control means you can control the brightness of the LED. So all these things you will learn. And here one buzzer is also there. This is an active buzzer. So you can make small tuning with the help of these buzzers. And we have 7 segment display and the shift registers. You will work with these shift registers, everything. Okay. As of now, we will see how this multifunction shield will be helpful for us to learn this Arduino. So I'm going to open Arduino IDE. So this is an Arduino IDE, and I would like to show you one more thing. So this is that schematic diagram, means we can say line diagram, otherwise we can say uh, for any microcontroller, any electronic components, we generally get a data sheet. So this is such a data sheet of this multifunction shield. So how pins can be connected, this data sheet will be help us to understand. Here you can see LEDs are there in such a manner that 5 volts is internally applied to the LEDs, and these pins are connected to the microcontroller. This symbol is denoted that this pin can be used for digital purpose as well as pulse width modulation purpose. For this 12, there is no pulse width modulation property. So for remaining 3 pins, you have pulse width modulation property. Okay, as of now, first we are working with these LEDs. So we will see. Uh, for microcontroller, 10, 11, 12, 13 are the pins for which LEDs are connected. And before going to that one, I would like to show you how this multifunction shield is connected to the Arduino. So I'm turning on my camera. so that you can see this is my multifunction shield, and it is connected to this Arduino. So this is my Arduino. On top of this one, multifunction shield is placed. So now we are going to use this multifunction shield. Okay, so let us use this one. So this is our program. So this is an Arduino IDE. IDE is generally used for writing this Arduino program. Okay, so first of all, we need to create an environment here. So we need to check whether we have connected Arduino properly or not. For that, we need to select board. So here you can see uh, for this port, Arduino is connected. COM368 is an Arduino connected board, and we need to select which board we are going to use it. So our board is Arduino Uno. You need to select board manager. Oh, sorry, go for the tools, select board, Arduino Arduino AVR boards. In that Arduino Uno, you have to select. Good. So now what we are going to do is we will test this one with the help of turning on our LED. Okay. So we will write a code for turn on our LED on the board on multifunction shield. So LED means it's an output. From microcontroller, you need to give digital output to the LED so that our LED will turn on. This is our process. So we need to set the pins of the microcontroller. We need to tell microcontroller pins, you need to communicate, you need to send signal. So our pins should be output pins. So we need to configure microcontroller pins. For that, we have one command, pin mode. Okay, pin mode. So we have 10, 11, 12, 13 are the pins which are connected to the LEDs. So 10th pin is an output pin. We are saying this is an output. Okay, now coming to the loop, we are going to use this pin, means we need to turn on our LED. As per our uh, data sheet, if this is 10, 11, 12, 13 pins or 4 pins are there, if you give 0 to the 10th pin, our LED will turn on. Okay, so we need to write command digital write. This is the command. Once you write properly, it will change its color, and you need to write it 10th pin low. So, so this is the command. Now I'm going to turn on my camera to check whether it's working properly or not. So first I need to compile this program. Yeah, it's okay. So after compiling, I'm uploading. So here you can say done uploading, and you can see in this microcontroller. So here one LED is glowing. As you can see, only one LED is glowing. But here bright, because of the heavy brightness, you are not able to observe properly. But here one LED is glowing. Okay. If you work directly, you will understand. Now I will make a small adjustment here. Now I'll do one thing. I will blink this LED so that you can see clearly. So for blinking, so in the same program, this 10th pin is an output pin, but here I'm going to create a delay of 1 second. So 1000 means 1 millisecond. 1 second, 1000 means here delay 1 means 1 millisecond. Delay 1000 means 1 second. So same code, digital write 10th pin comma low. Again I need to give delay. So 1 second on, 1 second off. and this will be repeated because it is in the loop. So it will repeat unlimited number of times. So I will just send this code to my microcontroller. So now it is uploading, done uploading. Now you can see, now it's an on condition. So it's on. You have to observe carefully. Sorry, here I made a mistake. Here you can see two times I made low. It should not be low, it should be high. So be careful while writing any code. So okay, let me just send a code. Microcontroller won't do any mistake. Generally humans do mistakes. So here you can see my LED is blinking. Yes, exactly. Our LED is blinking. So first program we have completed. So we have used digital pins to to communicate with the LEDs. Okay. Second program, what we are thinking is we will turn on all the four LEDs and we will turn off all the four LEDs. For that, we need to write a program. So all the four LEDs means for one LED I have made one pin mode. For four LEDs I need to make four pin modes. So I'll copy the same thing. Okay. So this is the 10th pin, 11th LED, 12th LED, 13th LED. Same thing. I will copy the same thing. So I'm going to change the numbers 11, 12, 13. This is same 10, 11, 12, 13. Now I'm just uploading this code to my microcontroller. Now you see all four are turning on, turning off, turning on, turning off. So now you can observe all the four LEDs are on and off. Okay, fine. So next what we are going to do is we are going to use one switch. Okay, before going for the switch, I would like to give some clarity here. Don't use these pin numbers like this, like digits. Always use variables. Variables will help us in order to reduce the mistake while communicating with these devices. Okay, so I'm going to use variables like int LED 1 is equal to 10, int LED 2 is equal to 11. Same manner, we'll copy. So this is 12, this is 13. So here I will replace 10 with LED 1. This is LED 2. This is LED 3. This is LED 4. So here always 10 is replaced with LED 1. So 11 is replaced with LED 2. 12 is replaced with LED 3. button is replaced with LED 4. So in this way, what is happening is we are reducing these values. Now delay, we don't want numbers to be in the program, so we will write one more integer int for delay time. Delay time is equal to 1000. 1000 means 1 second. So here we are going to copy this delay time. Okay. Now you see the program is we have modified this program beautifully. Now I want to change delay time to 100. So I can change here. So in complete program, I no need to modify it. So one time modification can be helpful in this program. Now you see, I have uploaded this program into my microcontroller. Yeah, some mistake I did it. Two times I have used LED2. Sorry. Here this is LED3. This is LED4. Sometimes I may make mistakes. Now you see, now it is blinking, but it's blinking very fastly with high frequency. Okay, 100 milliseconds. So 10 hertz frequency. 100 milliseconds is 10 hertz frequency. Okay, so it's blinking very fastly. Now we will make a program. We will now already we have used LEDs. Now we are going to use push buttons now. Okay, now for using push button, we need to understand something clearly, that push button is our input to the microcontroller. So you are giving some data to the microcontroller. So after giving data to the microcontroller, you need to see what data you have given to the microcontroller. Okay, so now we are going to see regarding push buttons. So I'm going to remove all these things. This is not needed right now. Okay, for push button, we are having three push buttons here. You can see in that datasheet we are having three push buttons. These three are push buttons. Push buttons are given to A1, A2, A3. So three push buttons are given and it is connected to the ground. On top of this one, say if you don't turn on this push button, A1 microcontroller pin will receive 5 volts as input. Means 5 volts means a digital one. If you turn on this push button, this is ground is connected to this A1. So A1 is modified to 0. If you don't turn on, it is 1. If you turn on, it is 0. Okay. If you press, then A1 becomes 0. If you don't press, A1 become 1. Now we will see how it is recorded in the microcontroller. So we are having three push buttons, A1, A2, A3. Okay, as per our data sheet, it is A1, A2, A3. Now we will record this one. Okay, so here also same thing, int push button pb1 is equal to a1, int push button 2 is equal to a2, int push button 3 is equal to a3. Now push button is our input to the microcontroller, so we need to say my push button is input. So we will say with the help of pin mode. Write pin mode push button 1 pb1 is my input. Okay, push button is my input, but I want to see this push button is input. What if I press? I want to see 0, so I can see data within the serial monitor. So in order to see the serial monitor, we need to enable one more thing. We need to write enable serial monitor. For that, there is a command called serial.begin begin 9600. This is one baud rate. In that baud rate, this serial monitor will open and show us that input data here. Okay, so I'm opening this one. Now coming to loop part, means in loop only everything will be executed. So it is a digital read. Previously it was digital write. Now it is digital read. Digital read. Okay. So digital read. What you want to read is push button one value you want to read. Digital. Okay. So now I'm going to read it. Digital read. Where this value has to be stored. So I will create one more variable here. Okay. This variable in k is equal to. Okay. So this value is stored in the value variable k. Now I will print this value. Okay, print ln. Ln means it will go for the next line k. Okay, I'm printing this one. But where it has to print? It has to print in the serial monitor. So you need to write serial dot print. Okay, so print means where it has to print. In serial monitor, it has to be printed. So we are using serial print. Okay, now we will run this one. Compile this one. If any errors are there, then it will show us. Yeah, some error is there. Here you can see in what is this error? A1, A2, A3, push button PB1, PB2, PB3 equal to A3 only, no? So we will check. So this is A1, A2, A3. Fine. Then where is our error here? We need to figure out this error first. Error unqualified ID before numeric constant. Integer is not qualified. Okay, let us put some hash. Okay, I'll remove this one and I'll check once again. What is error? Oh, so something is missing here. It's A1, A2, A3. Exactly. Now you see, there was one error occurred here, PB1. So generally PB1 means that is a port B. So we have used that port B. So microcontroller got confused. Okay, this is push button 1. Now it is working fine. So we need to modify this one, push button 1 with our previous PB1. So microcontroller is confusing with PB1. So don't use PB1, use push button 1. Okay. Now we'll see how it functions. Now it is compiled. Now we are downloading this thing into the microcontroller. Exactly. Now here you can see Here one serial monitor option is there. You open this one. Here one is printed. Continuously one is printing. Okay. Now I will turn on this. Now you see, this is my push button. This is my first one is first push button. If I turn on this push button, you can see 0 is pressed. Now if I open, 1 is coming. 1 means 5 volts. If I push, then 0 is coming. Otherwise 1. Okay. In this way, we are going to read the push buttons. Okay. Now what I'm going to do is, if I push, if I press my push button, my LED has to glow. Otherwise, my LED has to turned off. So this is my condition. Okay. So then I will write a program here. You can see. Then LED has to come into the picture. LED means again I need to tell microcontroller I have one LED that is my output. That can be done with the help of pin mode. Pin mode. Previously LED is defined. LED 1 is equal to LED 1 is my output. So this is my output. So I told microcontroller this is my output. Now you see I will make one condition. If k is equal to 0, k is equal to 0, then blink my LED means I need to turn on my LED. So for turning on my LEDs will turn on if I give low input. Okay, digital right LED 1 comma low. Fine. So I made a small program here. Okay. Now what I'll do is I'll compile this one. Fantastic. No errors are there. Then I will download my program to microcontroller. Now you see. Come. So this serial monitor. Fine. Serial monitor is ready now. And the LED is also. Oh, sorry. LED is in low state. Means low state means initially I had to tell LED. Oh, LED always turned off. Okay. So k is equal to 0 means LED has to turn on, but it is always in on condition. It is not listening my words. Let us debug this one. Okay, at least this is my listening my word. Okay. Otherwise LED state I have to tell it. I have to tell LED state now. So otherwise digital right LED be in off condition. Okay. See, I have made my LED turn on if k is equal to 0. Here is equal to 0 is not happening until I push my switch. So LED has to be on off condition now. So that one that's why I'm writing this line of code. So digital right LED one high. High means off condition. Now see what happens. Now I send this code to the microcontroller. Now see. Uh, so now microcontroller all LEDs are on off condition. You can see. Now I'm going to press my this one. Sorry. Yeah, it is glowing, but very light frequency it is glowing. Don't know why. There's a very light frequency, light intensity it is glowing. Maybe low. See, I'm turning on with very low. See, you can see very lightly it is glowing. I'm turning off. So in this way, LED is functioning. It's okay. Anyway, LED is working. Okay. So in this way, we can use digital inputs and digital outputs. Digital input means you are giving input through push button. Digital output means you are taking output via LED. Okay. Now we are going to use potentiometer. Here you can see, here one potentiometer is there. We are going to use this potentiometer. And okay, now we are working with the potentiometer. Coming to this data sheet, here you can see, here potentiometer is connected at this position. So this is potentiometer. We have 10 kilo ohm potentiometer, and this potentiometer 5 volts is applied to the potentiometer, and the second terminal is connected to the ground, and third terminal is connected to the microcontroller pin A0. Okay, so here this is input to the microcontroller. Okay, you are giving input to the microcontroller, and that input is also continuous. Okay, analog pin you are going to give, so analog input you are going to give to the microcontroller. Now see how this potentiometer works. Here you can see potentiometer here. This blue color one is the potentiometer here. This blue color one is the potentiometer. Pot, we generally say pot, and this is an input to this microcontroller. Now I will help you to write a program of potentiometer. First we will define potentiometer. Okay, we will define in pot. Pot is connected to A0. Okay, this time also I'll compile and check whether pot is also somewhat internal, it is defined to internal purpose or something. Say one error occurred here. I forgot to make a semicolon here. So it is saying unexpected comma or semicolon before the integer. So before the integer there is an unexpected. Now I'll just make a semicolon. Now we'll check this one. Yes, fantastic. Now I can use pot. Pot is connected to the A0 as per our data sheet. Okay, so part is an input to the microcontroller. Okay, now you see, we need to tell this pin mode. Pot is my input, so you have to tell. So how you can tell? Go for pin mode. Okay, pin mode, pot is my input. LED is your output, pot is your input. Okay, so now pot value is here. Okay, now in the same value, here you, for reading with push button you have used digital read. For now you have to use analog read. Okay, I'm not going to disturb this one. I will create my own code. uh, shall we remove this part? I think it is not needed right now. uh, I hope it is better if we remove this part because it is not in use, and we will write integer k. Okay, I'll remove this part also. Push button also we are not using right now, but I want to show you something. That's why I keep this push button. Okay, let it be. Int l, k l. L is my, I'm going to read the value of what in value l. Okay, so now I'm going to change small things. Okay, I will tell you where I'm going to change this. Analog read. This is my analog read, and I'm reading port value. Okay, port value is recorded here. Now I'll print port value. Print ln l. Okay, but small changes I will make it here. Here k is there. I'm removing ln command, and here I'm going to create some space here. Okay, serial dot print. This I'm creating. You will understand why I'm doing this one. And here I want to write one more serial print command. Okay, before that one, it's okay. I will show you something. Now L value is recorded in the serial monitor. Okay, now I'll compile this one. Some errors are there. What error we occurred here? This is L now. This is small p. Okay, now it is compiled. Now I'll send this program to the microcontroller. Fantastic. It is uploaded here. Now you can see. The first value one is of push button. Means the first value is the K of push button. K value is reading here. Now you can see. If I press this one becomes 0. Okay. Second one is your pot value. Here you can see I have used one screwdriver here and I'm varying this one. You can see value is changing. Here your potentiometer value is changing. I'm rotating and your potentiometer value is changing. And the maximum value of potentiometer is 1023. So it varies from 0 to 1023. So it has 1024 values. Okay. So 5 volts is 1023. So 0 volts is 0. So it ranges 0 to 1023. Means total 1024 values. Okay. Now I have to you should get some clarity now. So I will write push button value is here 1. So in order to write on the serial monitor, we are going to use the command serial print. Okay. Uh, Serial dot print. I'll write push button value is 1, and I will write in the same manner the value of pot value is something. Okay. Now you see I will send this command to here. Now it looks somewhat beautifully in the serial monitor. Okay. See, push button value is 1, pot value is 1023. So in this way you can means for user it is easily understandable what is 1023 and what is 1. So in order to make communication between this IDE and that serial monitor, we have to use serial communication, and we have used baud rate 9600. So here you can see in the serial monitor we have used baud rate. Now I will change baud rate to 19200. Now you can see there is nothing is printed here. Now I will change here also baud rate 19200. Now you check this one. So if it is in the same baud rate means it will function. If it is a different baud rate means it won't function. So baud rate means a higher baud rate means more fast operation you can execute. But generally we use a 9600 baud rate. So I told you the same thing. You can use whatever baud rate you wish. We are having different baud rates, so you can use that baud rates. Okay, baud rates is a one communication protocol between this IDE and the serial monitor. Okay, if you use different baud rate, like if you want to listen in 93.5 FM, you have to use 93.5 FM frequency only. If you use other frequency, you won't listen. Okay, just like same thing happening here. So you have learned regarding potentiometer. Now we will do something. 1023 is 5 volts. So we will tell this microcontroller I am applying 5 volts. So how can you say this one? So assume 5 volts is 1024. 0 means 1. Okay. So we will make a scale equation and we will write a small code here. Okay. So pot rate. Uh, so in voltage V is equal to how much? We are going to apply, we have applied voltage is 5 volts. So y-axis is 5 volts. 5 dot, and this is 1023 dot, and here I have made dot so that it is converted into floating value, and I'm going to multiply with L. Okay, and this is my float, because if 5 is divided by 1023, means as per integer it will show 0. If it is float means it will show particular value. Okay. Now I'm going to print float. In the same way, I'll copy these two terms. So I will change this one to ln, and here pot value is something and pot voltage is something. Okay, there is a small difference, and this is not, yeah, this is big. Okay, small bit. Now you can see what is the voltage applied across this potentiometer. Okay, now we will do one thing. We'll compile and check it. So before doing that one, everything is fine. We need to check any spacing. Okay, we'll check. Fantastic. Compiling is done. Now we are uploading the program into the microcontroller. Fantastic. Now you see. Yes, exactly. So previously we have used double quotes and created some space. Now we are not used double quotes, so no space is there. Now you can see 1023 represent 5 volts. Now I will vary this one with the help of, you see, I'm using screwdriver and I'm reducing this pot voltage. Now see, pot voltage is reducing here. Based upon the value, your voltage is reducing. Okay. So this is the way we can read unlog values. Okay. So you have learned unlog input, how to give unlog input with the help of potentiometer. Now you can do unlog output based upon the brightness of the LED. You can control it. So how can you control this brightness of the LED? Simply, I'm going to apply this voltage to the brightness of the LED. Okay. So I will do one thing. Uh, I will write it like analog output. Okay. So pin mode is there. We have removed all the LED part now. So I'll write analog. Uh, read is there. No, digital read is done. Digital write is done. Now analog write. Analog write. LED 1. LED 1. Otherwise, shall we take LED 2? Yeah, LED 2 is also fine. Always by LED 1. And this one value will be given by our L value. Okay. L or V, whatever it is, okay, fine us. So now we will do one thing. We will compile this one. Now check this one. Ah, now we will vary this one. Based upon this one, we will check whether our LED value will change or not. So we are reducing this voltage. At one particular point, our LED has to glow. We have used a second LED. So I'm reducing this voltage to 0. Okay, fine. So we're not able to see big difference here. So we will write, we'll change the small values to here voltage. Huh. So now we have used LED 2. So previously we have to check which LED. LED 2 is 10, 11. So this is the 10th pin and this is the 11th pin. Okay. And here we have seen we have to change LED 1 to we have used LED 2. Okay. Now we will modify this LED 2 value based upon our input. Now applied voltage is 0. So our LED is glowing. Now I'm reducing this voltage to 0. So LED is glowing. Now I'll increase my voltage. Okay. Now you can see I have increased my voltage and see what is the condition of the LED. See, you can see that the brightness is reducing here. LED brightness is increasing. As voltage is increasing, your brightness of the LED is dimming. So brightness of the LED is reducing here. At one particular point, you can see a very large impact will be across this LED. Now you see, okay. So LED is turned off at a maximum value or LED is turned off. So in this way, we are going to control that analog input and analog output here. Okay. Now we are going to work with the buzzer program. For this buzzer, I'm going to remove all this in loop part. I will remove all this stuff. And okay, here also I'm removing all these things. I will write for buzzer is connected according to the data sheet. It is connected to the pin. So pin 3. So buzzer is an output element. So it is connected to the pin 3. So we will activate buzzer now. Okay. Now coming to the buzzer in buzzer is equal to pin 3. Okay. So as per the data sheet, buzzer is connected to the pin 3. Now we need to tell pin mode that our buzzer is at pin 3. Okay. So in that void setup, we need to tell pin mode buzzer is output. Fantastic. Now we will write buzzer with different frequencies. We will operate buzzer with different frequencies. Okay. First we will make high, low. Means based upon that we will okay do that one. So digital write buzzer to high. Again here we need to give delay. So delay already we have delay time. Again copy this one. Same paste it here. Here high is there. Here I'm going to change to low. And delay time is common. Okay. Now I'll compile this one. You see. Now program is compiled. Now you can see small voice is coming here. You can observe voice. That is buzzer based upon the frequency. Now I'll increase the frequency. Now you check it. You can see the tone. Tone is varied here. Previously, beeps were very fast. Now beeps are very less. Now you see, I'm reducing the frequency now. You can see some sort of high pitch frequency you're able to observe in the buzzer. So based upon that time period, I'm changing the buzzer frequency. So in this way, you can operate with the buzzer. So as of now, from the multifunction shield, you have learned how to operate with the buzzer, and these things you have learned now. Okay, just I'm diverting. I don't want to turn on my buzzer all the time. Now my buzzer is turned off. Okay, now we are left with one more thing, that is shift registers and 7 segment display. Okay, here you can see the shift registers. So shift registers, it is MC74HC 595AD. Two shift registers are there. Here we are going to give data serial input, and output, we have parallel output as well as serial output. So 8 is, if you give data, means for example any number, for example I'm giving number 7 at the 14th pin. If you turn on this one, here we are having two clocks. One is the latch clock, another one is the shift register clock. If you turn on shift register clock, output will be displayed at this point. If you turn on the latch clock, output will be displayed at the parallel output. Okay, here we are having two clocks. And here you can see this serial input data is connected to serial input of the second shift register. If you turn on the serial shift register clock, so at one time, this clock data will be shifted here. And here two shift registers are used. One shift register are used. So here four 7 segment displays are there, which 7 segment display would be turned on. Okay, for that here four lines are there, and on the 7 segment displays we have varies from 0 to 7. So 8 values will be there. So based upon that 8 values, so which LED has to glow. Okay, for that these 7 lines are utilized. Okay, now we will write this program so that you can understand very well. Okay, so we will take a new program, new file. We am taking this new file, and we will work here. So I told you, in the shift registers we are having two clocks. One is the latch clock and one is the shift register clock. And we have data. Data is our input. Okay. So data is input. Clock is also, means data input to the shift register. Means this is an output module. So always write in pin mode. All these components are output only for us. For microcontroller it is an output. For shift registers it is an input. Okay. So from microcontroller, we need to have three things we need to take into consideration. One is the data from the microcontroller has to be printed in the 7 segment display. Microcontroller has to trigger shift register clock as well as the latch clock. If you want more clarity regarding this data, you can go to the data sheet of this shift registers too. Okay, so this is the shift registers we are having, and here this is the 7 segment displays. So previously we have worked with these push buttons and these LEDs and this buzzer. So we are left with this 7 segment display. So previously you have defined anything with the help of integer. Now I will help you to define in one more way. You define, use define command. If you know C, you will understand define is also used. Okay, latch digital DIO, digital IO module. Okay, so this is fourth pin, means it is already connected to the fourth pin. Here you can see it. So This is latch pin is fourth pin, the shift register is the seventh pin, and data is connected to the eighth pin. So that's why I have placed here fourth pin. Okay, again, hash define clock, CLK. This is also DIO, means a digital pin. Okay, digital input output module. Okay, so I'm going to use seventh pin as per our data sheet. Again, define. We have latch clock is done, shift register clock is also done. Next, what is the thing is left over? Data. Data DIO. So this is connected to the 8. Okay, so three things are defined now. Now what we are going to do is we need to map data from 0 to 9. So it is a 7 segment display. I will show you, but before that I want to show you how it has to be mapped. Okay, uh, we need to check the data sheet first. So you need to check the data sheet of this module first, then you will understand why I told you this one. Sorry. So here shift registers are provided now. 74 HC 595 data sheet. 74 HC 595 data sheet. Go for this data sheet. So I have opened this 74 HC 595 shift register data sheet. Okay. So in order to give some clarity for you, I have opened this one. Here you can see shift register is there. One more term is there, latch. For shift register, one clock is provided. For latch, one clock is provided. If you turn on the clock of the shift register, this data from A will come to this point. Okay, this SQH is the serial data output. Whatever you give here, it will be reflected at this point. If you turn on this clock, so whatever the data at these parallel points will be reflected at these points. Okay, so here two things are there. For that you require two different clocks and one data. Okay, first clock is the shift register clock, another is the latch clock. So in this way it is assigned, means this is that pin description here, and here you can see this is the timing diagram. You can go through this data sheet and you can understand here. So in this way it will be there. So three things you need to give here, and in this way you are going to get parallel data output. And for 7 segment display also you require something, so that one also I want to show you. Okay, I'll do one thing. So I have copied this one. For example, in order to print the bit 0, so I need to make this bit is converted into 7 segments. So This way I will make this into 7 segments, and 1 is written in this manner, 2 is written in this manner. So hexadecimal value of 2 is this value, and hexadecimal value of 3 is this way. So in this way we are going to write it. 0 means hexadecimal value is 0 cross C0, and 1 means 0 cross F9. So in this value 1 to 9 value is hexadecimal values I have written here. So if I want to print 1, so all these 7 lines has to be means 7 lines has to be filled with some value. That filled values will be displayed across the 7 segment display. Okay. So now we will write a code here. You can understand this one, I think. It's not that difficult, but you need to put some effort to understand here. I will write constant byte. Previously, we are writing everything in terms of directly. Now we are going for byte operation. Segment now. And segment is mapped here. Okay. And I'm giving values in this manner. So I'm creating one array here. So you will understand. Arrays will value means if I don't write anything means it can have n number of arrays. The first value is 0 cross C0. Second value is 0 cross F9. Third value is 0 cross A4. Fourth value is 0 cross P0. Fifth value is 0 cross 99. Sixth value is 0 cross 92. Seventh value is 0 cross 82. Next value is 0 cross F8. Next value is 0 cross 80. Next value is 0 cross 90. So you'll check 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So in 7 segment display, you can print only numbers, and that numbers varies from 0 to 9. So for every number, we have one particular operation, one particular hexadecimal value. So it is under segment map. Next, we need to select which 7 segment display you have to select it. For that one also in the same manner you have to write, but not this much big code, small one. Constant, again byte. Okay. Then which one you have to select? Segment select. Okay. Same thing. Okay. This is for 0 to 9, and the second one is for selection. 0 cross F1. Next 0 cross F2. Next 0 cross F3. Next 0 cross F8. This is not F3, it's an F4. This 0, 2, 4, 8. Okay. For this, in this way it will be written. So two things, we have written everything properly. First one for mapping, second one for selection. Next, come to this void setup. Here we have to tell what pins are for what purpose. So we are going to use pin mode. Pin mode. First one, latch com DIO is an output pin. Select this one. Put here, write output. Previously, while writing pin mode, it was color was changed. Now it is not changed. Now it is changed because last time I read pin mode, not pin mode. Next one. So all three are an outputs only. So I'll copy the same thing and I will replace block IO second time. Third one is the data IO. Okay, fine. Now coming to the loop part. In this loop, what we have to do is we will write it in such a manner that whatever you want to select. For example, uh, we will write in such a way, in loop whatever you write it, that will be printed in the 7 segment display. Okay, but here we are going to use one function. In loop we will call into the loop to that function. Okay, we will do function called write number to the segment. Otherwise we will call this function write number. Right, you write this one properly, so that you have to understand later point of time. It is not like uh, I'm using simple variables. I'm writing these variables clearly so that for understanding purpose. 0 comma 0. So first what we are going to select is 0 comma 0. We are having four 7 segment displays. First one 0 means first 7 segment display you have to put 0. In the same manner, second 7, I have four 7 segment displays now. For every 7 segment display I'm going to select such a, so 4 times I will print the same thing. So second 7 segment display I'm going to print 1. Third 7 segment display I'm going to print 2. Third one I'm going to print 3. Okay, so in this way I have copied here. So now you come to this function part. Okay, function part. This function does not give again back any data, so I'm going to use void function. Same thing, copy this thing. Otherwise you will make mistake. Function is copied. Okay, first one is we are going to latch PIO. Next one is first one you are going to latch it. Second one data pin. Okay, so that is your clock pin. So always this thing will work in such a manner that uh, first you need to make this latch pin high to low, then only it will function. Okay, so before that one we'll do one thing. This is a function. No, first we'll create a function, byte segment, segment. Next byte value. Okay, first we are selecting the which segment, next we are selecting value. Now this is our function. Our function is created. Now whatever we write in the function, that should be executed. Okay, so digital write. Digital write means either it will be 0 or 1. So first we need to make latch to low. Latch DIO comma low. So latch is low means it will come into the 7 segment display will be executed. Next, shift out. This is one command for shift registers. You have to remember this one. Shift out. And first one you have to give data. Data.dio. This is first you need to put data in the shift registers. Next, clock. Clock.dio. Clock pin has to be set. Next, we need to tell either it is MSB or LSB. Means MSB means one type of hexadecimal values you have to print it. LSB means we need to give another type of hexadecimal values. So these things you can go through internet and check it. So I'm going to use MSB first. Okay, next I need to map to the segment. Okay, segment map. Here value. Okay, so whatever is there, that will be here value. Whatever is there in the second column, that will be reflected here. Okay, next same thing we need to copy, but here segment map is done. Next we need to select segment select, copy the same thing. Here two shift registers are there, so you have to use two times this code. Okay, now this one is there, segment map. Now you need to select segment select. So which segment you are going to put that value. Okay, now it is segment. This is the first one now. So this is the first segment. Second value you have to put it. This can be interchanged, no problem, no issues will come based upon your convenience. After doing these things, you need to turn off the latch. So digital write latch dot dio to high. So high means it will turn off the latch. Okay. Now everything is written properly. Now we will compile. If any errors are there, we will check this one. So as of now, no errors are there. Now we will put this one into this microcontroller. Now you can see I have print 0, 1, 2, 3. Here also you can see it. Here you can see it 0, 1, 2, 3. Okay. Now I'll change these values here. 0, 7, 8, 9. I'm just sending this one to my multifunction shield. Now you can see 0, 7, 8, 9. Now you're able to see this one 0, 7, 8, 9. So in this way you have to print everything here. Okay. Yeah, yeah, fine. So 0, 7, 8, 9. So values is displayed here. So in this way you're going to use 7 segment display. So we have learned in the multifunction shield different input output parameters and many things we have gone through multifunction shield. We have used the 7 segment display, we have used buzzer, we have used digital inputs, and we have used digital outputs. And you can interface temperature sensor also, as well as Bluetooth module also you can interface. And one more module is there, that is a clock module also you can use it. In this way you can learn communication, okay, with the help of microcontroller. Thank you.